Hello, everyone. Jonah and I are coming to you today to work on our math lesson as promised with food, and I'm going to let him do it as if he's one of our students in our class today too. So if you were able to get a small little square food of some sort, we talked about Cheez-Its. We've got Cheez-Its, right, Jonah?
Life cereal.
Life cereal, or somebody asked me about Starburst, and I said that would work too, but we don't have any of those. So Jonah and I are just going to use little Cheez-Its that we bought from Aldi's. Show them the box, Jonah. So anything that's little squares will work for what we're doing today. Okay? Thanks, bud. So I'm now going to switch over to my other camera here. Give me just a second to click a couple buttons, and you're going to be able to see what Jonah has in front of him. And you can see he's got some Cheez-Its set up. So I'm going to talk to Jonah just as if I'm talking to you guys and have him try some different things. So if you did all your lessons for this week and did the first lesson on Thursday about area, you found out that area is measured in square units, not straight lines. We use squares to measure, just a minute. We use squares to measure area. So I'm going to ask Jonah to use 6 Cheez-Its and make a rectangle. And if you have little pieces in front of you, you can do the same. Use 6 squares to make a rectangle. Now, of course, these aren't absolutely perfect. You know, they're a little lopsided sometimes from the factory that they're made in or whatever. Okay, did Jonah use 6? Let's see, bud.
I have to make it.
Good.
1, 2, 3, 4, 5, 6.
So Jonah used 6 Cheez-Its. They are in a rectangle, a big, long, skinny rectangle. And so we say that the area of this rectangle is
2.
How many squares did we use to build it?
6.
6. So the area of this long, skinny rectangle is 6 square units is what we say, okay? And if they were inches, if we knew for sure these were inches, we would say it measures 6 square inches. But these probably aren't perfect inches, so we're going to say 6 square units. Now, Jonah and everybody, I would like you to take those same 6 square units and make a different rectangle. It doesn't have to be perfect. Awesome. Did Jonah get any more Cheez-Its in order to build this? And did you get any more to build it? Did you, Jonah?
No.
No. So what is the area of this rectangle?
6.
6 square units. Good. There's still square units because that's what we're using to build it. Okay. Now, hopefully this is not going to be confused anymore with perimeter, because when we were learning perimeter earlier this week, we were measuring the sides and then we put them out in that big long piece of tape. We're not doing that today. We're just using the square units. So let's go a little bigger. Hopefully you've got some extras there. Why don't we use 8 this time?
Sure.
See what you can build with 8 square units. Give me a rectangle with 8 square units. I bet most of you did what you see Jonah doing. And the area is
8
square units. We're just going to count our squares. 1, 2, 3, 4, 5, 6, 7, 8. 8 square units is our area. Area represents that space, right? The space inside of the shape, right? You all like to use the word inside, but we need to remember that we're actually looking at the squares, okay? Jonah, can you do a different one?
With
That
8?
still has 8?
Okay.
Really long, skinny one this time. Barely fits in our camera.
8 square units.
8 square units. Awesome. What if I ask you to do a shape? I won't say it has to be a rectangle. What if I ask you to do a shape that still has 8 square units, but it doesn't have to be a rectangle? Can we move them around and make a different shape but still have one closed shape and still have an area of 8 square
Wait,
units.
8. No.
It doesn't have to be a rectangle. How about that? Just leave it
No,
there.
no. I'm trying to make a trapezoid.
That's an interesting question. Can we make a trapezoid with these?
Trapezoid.
Well,
Kind
sort of.
Kind of.
Right. We can't actually make a trapezoid because a trapezoid would have angles on it that aren't 90 degrees, right? So we can't unless we bite them or something. We're not going to do that yet. We're not going to do that yet. So Jonah has made a closed shape, okay? It doesn't really have a name, but if I gave you a picture of this and asked you what the area would be, you're still counting the square units. So you're counting 1, 2, 3, 4, 5, 6, 7, 8, same area. So now we've been able to make 3 different shapes that all have the same area but look very different. Right?
I think you could ask your music teacher.
For what?
This is a music symbol. I don't know what it's called.
Oh, it is.
It's like a hat.
It looks like a hat. You're absolutely right. Miss Robertson would like that too. It's called a half rest. It's a rest that represents 2 beats in a measure. So there's our math integration for today. Okay, I'm going to give Jonah one more, and I'm going to ask you to make something that has an area of 9 square units.
It doesn't have to be a rectangle?
Doesn't have to be a rectangle. Make a shape that has an area of 9 square units. Oh, it's got to be a closed shape though, so.
I know.
Oh, okay, good.
Oh, I messed up.
Come on, they can't sit here all day. I don't want you off the page. They got to be able to see our work. So as you're working, as you're moving your pieces around, if you have them in front of you, does it matter what the shape is? Those are our extras. Does it matter what the shape is? Not really, as long as we are still using 9 squares, right? 9 square units, okay? So as you're working on your area problems for the next couple days, consider this, okay? You're only counting the square units. You can have shapes that look very different from one another. I thought maybe Jonah would have done this and made a perfect square.
I would have.
I didn't say you had to. And of course, a square is a kind of a rectangle, right? It's a special rectangle that just happens to have all the sides the same. But you can make a square out of these because 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, this brings us to multiplication. Because sometimes we might have a rectangle that we don't want to have to count all of the crazy squares inside. It might just be too huge, right? This one's easy. We can count 1, 2, 3, 4, 5, 6, 7, 8, 9. But imagine if this were way bigger. To save ourselves some time, if we are looking at a square or a rectangle, I got to pull some more out of the box here. If we are looking at a square or a rectangle, we can use what we know about multiplication arrays to know that we can just multiply. So we're going to go ahead and put, Jonah, watch. Everybody watch. We're going to go ahead and make another row. And without having to count these, we can look at this. Even if the squares weren't drawn, what if they were just labeled? What if it just said, let me grab a pen. What if it just said that the side of this rectangle is 3? Hang on. Ta-da! It's no longer backwards. What if the side of the rectangle is labeled 3 and the bottom is labeled 4? Don't you dare start thinking about perimeter. We're still talking area, right? But what if the squares weren't even there? What if I just had a picture? Because this happens sometimes, right? And you're being asked, what is the area? We still need to know the square units in there. So instead of drawing them, which we could do, right? We could sit here and then we could count them, but we can take a shortcut. We can know that this actually represents 3 rows of 4 Cheez-Its. So we can multiply our length times our width in order to get our area. Okay, and of course, all of this is based on back when you were little and you first learned multiplication and you found out that area is an array and we can multiply length times width. We usually write it like this: length times width, that's an L, equals our area for rectangles. Okay, so of course we all know, I'm sure you had it in your head for several minutes now, the area of this was 12 square units. Okay, so I hope that helped everybody. I hope you enjoyed that. If your parents say it's okay, you can eat your snack now, or you can build some more and have them have your parents work on some area problems with you. Say, give me a number, Mom, and then you can build. Jonah's eating his already. You can build a shape that has an area of 7 or a shape that has an area of 12 or whatever you can come up with. And again, we can have shapes. I'm going to switch my camera back just so you can see me again. We can have shapes that have the same area but look different, right? Because we did those that had the same area, but they look very different. So it is possible to have shapes that have the same area and are different shapes. Maybe it's a rectangle, maybe it's something weird with one little square sticking out, as long as it's all closed in and still a part of that shape. Okay, so I hope you enjoyed that. I wish we were in class. We would have been doing that together. Okay.
Bye.
Bye, guys.